I can't believe it's been a year since we did this last. It's crazy. But what I'm going to do today is just give you a quick run-through of a project we worked on just recently. And the reason it was interesting to us is because it covered a lot of things that we'd never looked at before, a lot of problems that we'd never considered before. So for those of you who don't know me, my name's Tim. I work for a company called Biff Bang Pow in the UK. We're based in Oxford, but we're fully remote, and we develop almost exclusively in Silverstripe. So it's kind of everything we do pretty much starts in the Silverstripe environment. And we actually, in our client portfolio, we have a number of clients who work in what we call the built environment, the office spaces, reception rooms, public buildings, this kind of thing. And so as a result, we deal with a lot of this kind of product. So these are glass partitions, glass offices, these modular systems that get installed. And we've got a couple of clients who operate in this sphere, and they tend to work in very different ways in terms of how to sell those products. It's a very difficult product to sell in a lot of ways because of the complexity of the project, the number of variations you can have in a product, and how you present that to the client. Now, some of our clients go down this route. They will start off with these curated architectural pictures, which are all very aspirational, all very clean, all very idealistic about what the products are. And as you can see, there's a huge number of variations in here. There's curved glass sections, there's sections with solid walls, there are all these extra finishes, fluted glass, all of this kind of stuff that's really difficult to get across. So some of the clients take the approach that actually we're just going to show you what you could have, get you to pick up the phone and have a conversation with you. On the other hand, we have clients who prefer a lead generation approach. So they'll start off with gathering some basic information. How big's your space? What shape does the office want to be? How many doors do you want in it? That kind of thing. And then once you've gathered all of that data, once again, get in touch with us. And this was the bit that particularly we wanted to get rid of. We wanted to get away from this, we're not going to tell you anything until you talk to us approach. So it was different because obviously I can hear the salespeople in the room. I can hear them getting upset by giving away a sales lead like that. But it was actually really important for the client to be able to do that, to be really, really transparent about what they were getting into. And what they found was it actually created higher quality sales leads in the end because they weren't having to deal with all the people who thought, oh yeah, we'll just install some glass offices. We've got £5,000, that would be enough. And they realised actually that's not even close. That doesn't even cover the site visit. So the challenge for us was to try and get to the bottom of what the clients needed and what their clients also needed as well. So, sorry, this is really difficult. The monitor down here is not working, so I can't see my own slides, so bear with me. So these were the key criteria that we had to get to, in that they wanted to be able to show the client exactly what they were getting, work out real-time pricing information to actually, as I said before, give the client a guidance of what they may be expecting. They wanted to allow the client to build up a complete estimate of everything that was going to happen. So rather than just saying, well, yes, you can have one office and it's going to cost you this much, they actually wanted the clients to be able to say, we're going to put in a whole suite of offices. We're going to make a complete project build-up. And that then brought us into, as I mentioned earlier on, the complexities of what was going on. So there are a lot of interdependencies within these systems. And within all these variables, there are a lot of different variables, and we'll cover some of that complexity now. I'm going to push on a little bit. I'm aware we're short of time. So here are some of the key complexities here. So first and foremost, the spaces that we're working in need to be scalable. No two offices are the same size. Everyone's got a different space to deal with. We also needed to be able to deal with multiple layout options. So some offices will just be a glass wall with a door in it because it sits between two existing walls. Maybe you have a corner office or a freestanding office against a wall. So there are all these things which become a real problem when you actually want to automate how to price these up. Then you get into the details of the product. There are different framework types. There are different glass styles. There are different doors, and each door will only work with a certain glass style, or there'll be an acoustic performance requirement. So if you're dealing with an HR office or an accounts office, you have to have a certain acoustic performance so people can't stand outside and listen to what you're saying. And if you have that, then you've got to have a double glazed door. And if you have a double glazed door, you've got to have a framework. It gets very, very complex very, very quickly. And our initial client interactions on this became, as you can imagine, they became fairly detailed. There were lots of sketches on pieces of paper. There were lots of emails backwards and forwards. And there were lots of spreadsheets and calculations. And this part of the project was actually the hardest part, not least of all because the client didn't really understand how to do that job. It was a very human thing that these guys have been selling these glass partition offices for years and years and years, and they just do it. But when you actually try and codify that and enumerate that into a set of stages that a computer can then work out, they realized just how difficult their jobs were. And we had to not only get them to understand that, but understand it for ourselves. So the first step really we approached from the client end. So we looked at how we're actually going to try and communicate this information across. Layouts feed everything in this process. So the first thing we need to decide, what shape is the room? Is it going to be a square? Is it going to be an L shape? Is it a straight line? All of those things. And then we could deal with the detail. How many doors? What color it's going to be? Do you need privacy glass? All of these kind of various bits of information that we need to collect. And then once we've got that, the plan was that we would have a split screen layout with, on the left-hand side, an actual rendering of what the office would look like, and on the right-hand side, the form to be able to adjust and adapt those things in real time. Rendering was the key to everything in this, and that's where we dedicated quite a lot of prototyping time. My colleague at BBP, James, did actually quite a lot of work in prototyping and render research to try and find the best option for us to actually make this work. We needed something that was fast enough to do real-time updates. We didn't want you to have to sit there waiting for 30 seconds to be able to see what you'd done. We needed something that was versatile enough that we could tell it what to do easily, and we needed something lightweight enough that it would run in a browser. And that was one particularly that came back to haunt us a number of times as we went through testing. So, after a bit of looking around, we stumbled upon ThreeJS. Now, some of you may already be familiar with ThreeJS. It is a JavaScript library that sort of wraps itself around WebGL, Canvas, a bunch of other really cool stuff like that, and then throws in all of these extra really cool feature layers on the top to make the job of rendering in a browser really, really easy. It's well worth going and having a look. These are literally just, I grabbed a few screenshots from the ThreeJS homepage. These are all built into ThreeJS. They're all interactive models. You can do all kinds of very, very cool things with them. So it's well worth a look, and all the author credits for these are on the ThreeJS website as well. So I'm not going to give you a full in-depth guide to how ThreeJS works. It's a big topic, and actually their documentation is very, very good. So what I'll just talk about are some of the key concepts of how these things stack together, how they work, and then how we implemented that particular feature set to make this work in the browser. So in terms of the the 3D scene. A scene is actually a thing in 3JS. It is what you're looking at. It's fairly, obviously, a lot of this stuff is going to be familiar and intuitive to you. So you've got your scene, and within the scene, you're going to have a camera, or one or more cameras. We're dealing with a single camera at the moment. And you're going to throw some lights in there. So you've got a scene, you can see it, it's lit up. And all of that comes very, very easily with just a few lines of 3JS. Once you've got those objects set up, you can then put into that scene your objects, the things you want to put in there. And again, 3JS makes that quite simple. So there's a thing called a geometry object, and that is exactly what you think it is. It's a shape. It could be a box, it could be a sphere, it could be an extruded object. These are mathematically created geometries. So you create that object. You've also got materials. These are the surfaces of things. So you can say, okay, I'm going to create a material object, and it's going to have a blue color applied to it. It's going to be metallic. It's going to be reflective. It's going to show shadows, that kind of stuff. You can give all of these materials attributes. You've also then got textures. So a texture is, if you imagine literally just taking a bitmap image and wrapping it around some kind of object, that's what a texture is. And they obviously add a lot more realism. And then you've got these things called meshes, and they tie everything together. So a mesh, as you see in here, the mesh would take a geometry object and a material object, and that's something that you can actually then put into your scene. And last but definitely not least, you have other general objects. So these can be CAD models. You can have stuff from Blender, stuff from various CAD software. You can import those directly into 3JS, and they will render into your scene as little mini subscenes that you can interact with as well. So the really, really simple 4-step guide to getting something once you've got your scene up is you create a geometry object, like a box geometry. You create a material object. It may be a marble texture, maybe you give it a texture on there, or just a reflective surface. You create a mesh from that geometry and that material. You stick it all together and put that mesh into the scene. And you can do this again. All of these objects are reusable. So you can say, okay, great, I've now got this metallic box. So now I'm going to take that geometry object with a different material and put that into the scene. So it's all very, very reusable, and it's all very straightforward. And this is actually the end result that we ship to the client. This was the first release. So this is, I'm giving you the reveal in the middle of the talk, which is a bit weird. But what you'll see, so all of this on the left-hand side, this is generated in real time. These objects are all imported. The lighting is all done in real time. And then we've just on the right-hand side, that's literally an HTML form with a bunch of graphic controls to control what's going on under the hood, really. And I'm going to be brave and actually show you it live in a minute. So this is, it is a interactive, usable model, and that was the key to making this actually work and be successful. We did have a few specific challenges which came up. Now, bear in mind, we'd never done 3JS before this, so this was a huge learning curve for us as well. One of the things that became clear, and is a limitation that you need to understand about 3JS, is it doesn't do ray tracing. So if you're not familiar with ray tracing, the simple guide is, if you imagine a beam of light, a ray of light, it will be calculated as it goes through the scene, and every time it interacts with another object, it calculates exactly what that's going to do to it. Is it going to reflect it? Is it going to stop it? Is it going to split it into different colors? You know, that's how it works. Now, as you can imagine, that's an incredibly compute-intensive process to actually ray trace all of these things and the reflections and how the light comes here and reflects over there. 3JS doesn't support it natively, which gave us an interesting problem, because given that the walls of our scenes are all made of glass, 3JS is not capable of working out what happens to light when it passes through glass and goes to another piece of glass. because it doesn't know. It just, as far as it's concerned, it's all transparent. The light just goes through it. So what you end up with here, I don't know if you can see it, this is actually a glass top table. If you look at it, if you orbit up over the top of the office, you see this lovely smoked glass table. As you orbit down and look at it through the glass window, everything just goes transparent. And the same thing applied with some of the objects we started to test. So you'll get a nice green plant, and it's got leaves and all the rest of it. And if the leaves had any transparency in them at all to let the light through and cast shadows, when you looked at it in isolation, it looked great. When you look at it through the windows, it looked like a dead Christmas tree because all of the leaves just disappeared. So it was an interesting moment when we thought, well, we've absolutely nailed this. Oh no, that looks awful. The other thing we wanted to look at, the client originally actually didn't ask for movement in this model. They wanted a static rendered box of what the office would look like. ThreeJS just gives you movement out of the box. Once it's rendered the scene, you can orbit around it, you can zoom in and out, it just comes out of the box. So we had a choice, and foolishly, one would say, we actually showed this to the client and said, hey, look, you can do this, it's really cool. And they went, oh yeah, that is really cool, let's do that. We should have just locked the camera and walked away from it. We know this now, this was fine. But what it did mean is, with these differences in layout, as the client is orbiting around the scene, suddenly you could find yourself looking through the bottom of the ceiling, through the bottom of the floor, up through the glass, or behind the back wall. So we had to dynamically add zoom and camera limits on the scenes. And of course, these all had to be dynamically calculated because nothing is a known size. None of the variables are known. It could be a 3-meter wide office, it could be a 15-meter wide office. So all of the zooms and the field of view and the orbit limits, all of this kind of stuff we had to work out as we went along. Without question, the biggest challenge was just the sheer scale of the data we had to deal with. I mean, I know when we're talking about millions of records and things like that it's a different problem, but in terms of the scale of the interdependencies, that was a huge task here. And I think this is probably one of the only Silverstripe projects I've ever written where I've used every single ORM relationship type in order to make the data. There's has-manys, one-to-ones, many throughs, polymorph, you name it. Every single data type is in there. Every type of relationship is in there just to try and make these things work. And it comes back to what we were saying earlier on. If you have a particular glass at a particular height and you need a particular acoustic performance, you can only use a certain thing. And when you use that thing, you've got to use this door. And if you use this door, you've got to use this handle. And if you use this handle, you've got to use this latch. And then you can have all of that in 3 different colors. So the amount of data logic in there was actually quite a challenge for us. So implementation, in terms of the way we implemented it, we divided and conquered. As I say, my colleague James focused a lot on the prototyping and the rendering and making that rendering engine work. I tended to deal with more of the Silverstripe backend. So there are 2 things going on in this project. One is that we had to give real-time pricing, which means we have to calculate all of the component part costs, the markups, which things can go with which things, all of the stuff I was just talking about. And we then needed to be able to render that in the front end without hard coding a bunch of stuff into our rendering engine. Because if the client wanted to add a new door, they needed to be able to add a new door in the CMS, set up what things it can work with, and then the JavaScript needed to be able to render it without us having to rebuild and recompile everything every single time. So we ended up with this fairly sane split, fairly obvious split. All of the information is managed in Silverstripe, in data objects. The pricing, all of that kind of stuff is managed in CMS. We had a couple of very simple controller endpoints, which the JavaScript could talk to get its information. And we had a bunch of helper codes, a bunch of sort of standardized interfaces for all of these different things so that we could put pricing data in, rendering data, and so forth. And then the JavaScript was a configuration-led system. So it's as unopinionated as we could make it in terms of how to render things. And we just used a fairly simple JSON-based API. This is actually kind of the top level of that JSON-based API. So when the renderer says, okay, I'm ready to render a scene, what do you want me to do? The endpoint would spit something back like this and say, okay, there's a camera, and it's at this position. There's a floor, render in this floor, it's at this position. There's a ceiling, there's some walls, that kind of stuff. And all that would happen is our JavaScript would sit there in between this API response and the ThreeJS engine, which was just running in the background. And it would say, okay, I want to put a ceiling in. That's a box geometry. How big is it? It's there. What space is it? So you're operating in a 3D space, just X, Y, Z, 3D space. All of the positions for everything are done like that. And it's sort of a unitless environment. So as long as you choose what your units mean, it's as big or as small as you want to make it. Then you'll see we've sort of broken down the JSON into all of the various operations. Again, none of this is hard-coded in the JavaScript. That was really, really important. And it saved us a whole bunch of time when clients suddenly decided they wanted to add a new layout. Or, I mean, I know it's difficult to imagine having a client change their mind every day on a project, but you know, today it was the biggest office we're ever going to build is 10 meters. And then next week, we need to build a 20-meter office. Can you do that? So not having any of this stuff hard-coded into the CMS or into the JavaScript was really, really important. And again, there's the floor, the lights, all of these things were placed programmatically into the scene by the back end. The back end effectively just said, put a thing there. And the JavaScript went, okay, I'll do that. Now, doors are the bane of my existence. Most normal people would think a door was a fairly simple object. You open it, you walk in and out. And it's really, really simple. No, not even close. Doors, especially in this environment, they can have different widths. Some have frames, some don't have frames, some have hinges. I could do a whole StripeCon talk just about how to make doors. I won't. Don't worry. But again, the reason I bring it up here is the hardware. This is one place where we had to kind of abandon, or we chose to abandon, our don't hard code anything policy, because with things like this, so this is a little handle, and that handle, for the purposes of the pricing, we have to know how much the handle costs, but we also have to know that that handle goes with a little striker plate that's in there that you can't even see. But it's got to be there because we've got to price it in. And also, there are 4 hinges on that door, which you can't see from this side. They're actually rendered into the rendering, but you can't see them at the moment. So all of that stuff has to be there. And in order to make those things work, it became very apparent that they were too difficult to do, too complex to do using standard ThreeJS meshes and things like that. So they had to be objects. We had to model them and import them. And we did look at whether we could put that into the CMS. So if you wanted to add a new door handle, you could do it. But it was always going to take developer involvement to be able to do this, and the opportunities for the clients to break absolutely everything by putting something wrong in there. We just decided, you know what, if they're going to be putting new models in, that's a job they've got to pay for. That's a job that they need our help with. And this is exactly the type of thing that went on. So James would spend hours a day in Blender extruding pipes and bending pipes and working from drawings. Of course, none of this existed as CAD models. Everyone's, yes, yeah, we'll get all the CAD models for you. It's fine. Not a single one. So we had to literally take pictures, dimensional drawings, and build them up in Blender, export them, and then bring them across. So when you see in the JSON here, these are just our names for these objects. So in the JavaScript, it says if the handle is this type, lever handle for glass, load this object in, and then put it where I'm told to put it. So we kind of had a solution. It was starting to work. It was starting to come together. And we needed to start looking at optimization. Now, our key problems here, again, just came out of the blue a little bit and came from this desire from the client that it must work everywhere. This was a real thing. So the client wanted you to be able to take your iPhone on the train and start designing offices with real 3D rendering, which presents us with actually a problem, because particularly if you've ever done any work with WebGL, you'll know Safari and early iOS devices, WebGL problems are everywhere. There's pages full of them. And we actually had to draw a line and say, look, if you're working on anything earlier than iOS 13, it's just not going to work. And that's an Apple problem, that's not an us problem. So we also had specific challenges around speed. Obviously, a lot of devices, especially handheld devices, have got battery power, power-saving modes. The processor speeds aren't necessarily very fast. The GPUs are small. All of these things which limited what we were able to do in terms of the quality of what we could put on the screen. It was fantastic. I could put on my screen on my desktop machine. I could have a really nice high-quality rendering with shadows and reflections and all kinds of stuff, and you put it on my old HP laptop here. An hour later, it just gave up and set itself on fire and that sort of thing. So there was always a balancing act between rendering speed, image quality, and usability within the actual application. One thing that did help us was that we worked out fairly early that we should only render things, we should only ask ThreeJS to actually render things when something was changing. So normally, ThreeJS maintains itself. It just, you give it the scene, and it'll sit there and do stuff. And it'll take the user interactions, and it'll move them around, and all the rest of it. When we wanted to change things, we would give it this JSON object and spit all this data at it. But we didn't want it parsing that every single cycle if nothing was changed. So we took a really, really simple approach, and with every single request, we had it's just a timestamp, very simple timestamp, which the JavaScript would keep a track of and only tell ThreeJS to update its configuration if the version had changed. And that made a huge difference in terms of just reducing the load that ThreeJS was having to take all the time, whilst also dealing with user controls and that kind of thing. Lighting was a huge problem. Now, as was mentioned earlier on, my background was actually in lighting. I worked in stage lighting for years and years and years. So when we started off, there were lights everywhere. There was fill lights and spotlights and accents. It looked fantastic. But lights are the absolute performance killer in any 3D engine. Absolutely. Anyone who's done games development will know shadows, lights, and reflections kill everything. So when we have an office space, I'm not sure if you can see it, there's a lot of pools of light in that office space. Again, because we had a variable size, we don't know how wide or how deep or how tall this office is going to be, so we have to calculate where the lights are going to be. So we eventually got it down to quite a simple method of spacing lights within the scene, making sure that their size and the penumbra around them, the amount of spill, all that kind of stuff was all achievable. So again, this was a real balancing act for us. We wanted so much to make it look incredibly beautiful, but it was just never ever going to work in a lot of devices. This particular one was another issue that in fact, this was a bit of an own goal on our part. So in the wireframing stage, we had this inquiry builder. So the idea here is you can create an office, and you can give it a reference, and you add it to your inquiry. You go back and do another one, add it to your inquiry, and you build up this whole sales inquiry, which you then send off and get a site visit and all the rest of it. And in the transition from wireframe to design, our designer just casually dropped in these thumbnails into the inquiry. None of us noticed. We just didn't, we were blinded, we just didn't see it. So when we actually came to build this page, there was this moment of realization how the hell are we going to do this? But thankfully, ThreeJS did come to our rescue. There are functions within ThreeJS specifically to take screenshots. The difficulty we had here is the way that under the hood things are working. The WebGL, the underlying WebGL bit of ThreeJS is cleared between every refresh. It's for browser performance reasons, it clears it down. And when you take a screenshot, you actually need that bit there. You need that WebGL buffer to be there and active so that you can get it. So the easiest thing is you just turn it on. You just leave it on all the time so it's not clearing this between every refresh. But again, on a lower power device, that was an absolute performance killer, and it's a real gotcha. And it took us a while to understand what was going on. Thankfully, again, had we read the documentation a little bit better, there is an instruction on there which shows you how to effectively enable that in real time. It captures a single frame and saves it in the buffer, lets you take the screenshot, and then lets it all go again and clear down. But for a while, it was a bit of a moment because we weren't entirely sure whether we were going to be able to do the thing that we designed. So this might go horribly wrong because I'm now going to actually try and show you the thing working. Okay, let's just try this. Okay, so this is the default configuration. This is how it loads in. As you can see, we've got this office there, and I can zoom in and out of it. It's all in real time. It's actually remarkably smooth. This laptop is nothing special. This is like a Core i3 laptop from, I don't know, 2,000 years ago. I don't know quite what it is, but it's old. But you can orbit in and out, you can move in and out, and you'll see this is all ThreeJS. This is ThreeJS doing its stuff. If you look at the light reflections working on the machine, then it's all relatively smooth. I've lost my mouse, there we go. And what happens is, so now if I click this button, I'm going to, in fact, let's click just an inline office, what they call an inline office here. It now sends a request off in the background to the back end. It's all Silverstripe powered. That will return a price. That returns a price back down at the bottom, which you'll see down here, just shows you the price. It works out some finance charges, that kind of thing, if you wanted to finance it. And then the renderer goes off and says, okay, things have changed, tell me what to render. And it does exactly that. And it all happens in real time. As I say, let me just go back to a corner office. Bit of a slow connection. I'm telling you, never do a live demo. I said it to Elliot earlier on, but okay. So as you go down through the system, you also have the ability to change the type of scene. So this is a framed one, and then we get into things like acoustic performance. And this is what I was saying earlier on, that actually if you want a particular acoustic performance, you have to have a certain type of glass, and that will only work with a certain type of door, which is why the doors changed there. So it is all, as I say, very quick. And you'll notice as well the two ranges here, we change the rest of the scene. One of the reasons we put all of that other stuff into the JSON was so you could change, if you see the floor and the ceiling, everything, all that changes all at the same time. The bits and pieces inside are just standard models. So let's just make that a little bit bigger. Oh, no, not that big. That's not going to work. That would have made it crash. So we'll just change the size, and again, everything now recalculates. It's now bigger. All the lights have moved. Everything is there. And you have all of these options. As I say, this is literally, underneath here is an HTML form, just a straightforward HTML Silverstripe form. There's a bit of JavaScript over the top to add all of these fancy controls so that it looks pretty. So you can change, as I say, all of these bits and pieces. Then we get into the doors. This was, again, a particular client request. When you moved into the door section, the camera would update and take you straight in to see the detail of the door, which, again, was part of the reason we put the camera information into that JSON script, so we could control everything from the CMS. And you'll see, as I say, everything. Every time I make a change here, the prices are recalculating. You can add all kinds of cool things, like, I changed to exactly the same one, that wasn't very bright. So you can add banding and all of this kind of stuff to your glass. And then there's some really interesting effects that you can put onto the glass, such as this reeded banding. And again, this is quite fun because this does then affect what the light is doing in the back end. So all of this is just, we're not doing anything clever. I'd love to say that, look at us, we're geniuses. This is all ThreeJS doing its stuff under the hood. So if you have this, any kind of requirement for 3D rendering, and we're already looking at other clients as to how we can actually use these technologies, these bits we've learned in different areas. So it's well worth a look. And as I say, it's very, very easy. I will happily share any knowledge, such as it is, with anybody else. Let's just go back to this. And if you need any more information, obviously ThreeJS is fairly easy to find. They're very good, and the one of the guys who's very deeply involved in ThreeJS has his own website, which is a series of tutorials, real step-by-step stuff, and I guarantee you'll be amazed at what you think, what you're able to achieve. So that was a quick one. As I say, I wanted to get through it because I know you're all got far more interesting talks to listen to than mine. But yeah, there we go. That was how we did it. ThreeJS, as I say, if you'd like to have a chat, I'm always about.
Thanks, Tim. Thank you. Any questions for? All right, quite a lot. Let's start here. Okay. All right, great.
We're always worrying when there's lots of questions. No. I can hear you. No one else can.
Do I need to turn it on? Okay. Test. Oh, much better. Great talk. Awesome demo.
Thank you.
I've worked with a lot of engineers, particularly in game dev for factory simulators, which this is quite reminiscent of. And I've worked in such an agency before as a developer, particularly in a different framework. We used Drupal, but it brought back memories and particularly nightmares. I imagine there is quite a lot of human finessing going on with the engine itself, things like z-indexing and eliminating flickers. So since you were if I understood you correctly, you built this for a client
Yes.
as a technical vendor, and then they also sold it to their clients, right? So there's multiple companies involved.
No, so our client is a direct sales company. So they sell these systems and install these systems in buildings. Mm-hmm. So we were one step away from the end user. Really.
Okay.
Yeah.
Okay.
Yeah.
So how did you price them? How did you manage the maintenance of the engine itself? You know, the human finessing of making sure the new materials are in there correctly. That you might not get the quite same polish on a material or the transparency. How did you finesse the pricing of it? Ongoing. Thanks.
Okay, so there's a couple of questions there. One thing that we went through quite a lot in the early days of the development, we went back and forth a lot with development. We were quite fortunate that we didn't suffer too much with Z-indexing and clipping and all those kind of things. We did, but I don't know if you spotted it. Obviously, we've got all of these glass panels which render in as objects, but then we get to put these great big framework objects on the top of them. Underneath there, it's a mess, but those frameworks hide a lot of sins, a lot of problems. So you'd orbit around a corner and there'd be a gap in between there, or they'd be crossing or something weird like that. We were very careful about the maths. We spent a lot of time just doing maths to calculate everything. So the center of the office is not actually the center of the scene, annoyingly. So where you've got this big rectangular scene, the office might actually be over in one corner of it. So everything is referenced from the center of the scene, not the center of the office, which meant we had to calculate everything. And in some ways that made the job easier, because we couldn't take anything for granted. Nothing on the screen is free, nothing on the screen is placed without us placing it there. So it wasn't too bad. We tackled most of those problems quite early on, and they never really resurfaced again. So the maintenance really became, once the build was done, maintenance becomes, we want to add a new door, or we want to add a new door handle or something like that. Everything else, all of the pricing, the markups, the commissions, all of those things are all CMS managed. We don't need to get involved in those. The client can do those themselves.
All right, great. We had more questions. Sorry, we'll go back to you. Way back. There you go.
Well, first, thank you for the talk. I don't know if there's going to be more interesting ones. I thought it was really cool. You mentioned that the customer can manage all those things in data objects. It'd be interesting to see, because it's like a really complex model, how they are possible to do that. And I was wondering, are they actually able to do it? Like, do they understand the complications? Like, you said you needed a lot of time to get out of them how their products work. Do they actually change it themselves?
Okay. So that is a question I think we all understand. We all really identify with that question. Actually, Johannes, I'm happy to show you the CMS afterward. I won't take up everyone's time now. But what we had to do was, it's not a single model. There's lots and lots of models. So there's a whole set of data objects for the door frame and the door leaf and the hinge and all of these things. And then there are obviously relationships which pull all those things together. So what we found is that, I've got to be careful what I say a little bit. What we found is that the client was very competent, very happy to be able to manage all of those individual models. Where it came to assembling those into things that would spit out valid render data, that's where the challenge is. Because you've got to really understand the structure of where everything goes. So that's where we had to do a bit of hand-holding. To be fair, for the most part, that's not what they're doing. Once we're kind of set up, mostly they're interested in, is the price right? Are we making enough money on this? Has it got the right components for this particular door? We're supposed to have 3 hinges, we've only got 2. That's the bit they're interested in. And just using standard model admins, standard grid fields, that kind of thing. It became, once they got it, it was easy. It was straightforward. Yeah.
All right, great. We have one more question. Yep.
I worked on something similar, a case builder, case configurator using ThreeJS as well. And my main question is, what was the motivator to do it in the back end? When we built the case builder, we had the demand that every component was draggable and droppable, like, for example, the door. Was there a reason that the door you can't slide it around, or are there possibilities that you went that route instead of doing it fully within the browser?
It was a number of reasons, really. There are commercial reasons. Obviously, that costs a lot more money to do in terms of front-end development. There were constraints in terms of how we were able to build the prices as well. So with these, without getting into too much boring detail, when you build a wall, it's built up of modules, and the modules have to have a certain place, and a door can only be in a certain place in there. So there are a lot of constraints which we would have had to build into the front end that would have added a lot of complexity to to the project, and the adaptability and flexibility. So discussions with the client, and from their position, they actually felt it was an unnecessary amount of complexity. Even though it would have looked cool, they kind of said, well, we'd never build them like that anyway. We would never let the customer decide where the door went. It goes here, or it's a completely custom build, not using the standard components and things like that. So we sort of, it was a number of factors to stop it. But yeah, it would be possible to effectively lock off the movement and then allow you to select objects and move them around. ThreeJS can do that, and it can feed information obviously back out after those events have happened.
Anyone else? Oh, yeah, great.
God, it's the boss.
So you're obviously, Tim, immersed in the world of glass offices now. Do you see that as where your career is heading?
Is this your way of firing me? Is this just a very public sacking that's happening?
No. It's a genuine question, because obviously the way how how good the client was with us around this is we're obviously going to be pushing for more of these type of builds. So I just want to make sure you're happy with that, really.
I probably wouldn't want to do another one of these, but yeah, I think the real eye opener for us actually in the project, joking aside, was it suddenly made us excited again. It's one of those things that we suddenly went, oh, that's really cool. We could do this with it. We can make car configurators. We can make office configurators. We've got other clients that have got systems that need user feedback, and actually these are really, really good natural ways to get non-technical people to interact with things on the screen and say, oh yeah, it's there. That's the bit I want. Just there, rather than working on drawings or things like that. So I think, yeah, it's from a technology point of view, it was new to us. I'm sure there's lots of people who go, oh yeah, ThreeJS, it's been around for years. But for us, it was new. It was fun, and it was an interesting project for us to work on for sure.
All right. Anything else? Anyone else? Great. Thanks very much, Tim. A big round of applause for Tim. Cheers.